Sayed Asnan here from BS Electrical. So today's my topic is measuring instrument. The instrument is very much important in our life, especially electrician lives. So let's get started. The measuring instrument are the eye of an electrician. An understanding of how measuring instrument operate is very important to everyone working on the electrical field, because they provide the electrician with the ability to evaluate their problem on the job through the use of the electrical tools. So let's start with the analog meters. The analog meters are characterized by the fact that they are used a pointer and scale to indicate their values. So here you can see a pointer, and the red one is a pointer, and the back of the pointer is the scale. There you read the actual values. And there are the different type of analog multimeters movement, right? The most common is the torsional movement. So okay, and here is the internal and simplified diagram of the diurnal movement diurnal movement meter. The spring is attached to the moving coil, and the pointer is there is the pointer, and the permanent magnet is with the center of the permanent magnet, the moving coil spring and the pointer is situated. And then the voltmeter. The voltmeter is designed to connect directly across the source of the power. The lead of the multimeter or the meter is directly connected across the source of the voltage. Like there is the positive and negative connector, and the voltmeter is directly connected to the source. The industrial standard for a voltmeter is 2000 ohm or 20k ohm per volt for DC. It means the internal resistance is 200k, and 5000 ohm or 5k ohm per volt for AC. So let's jump to the multi-range voltmeter. Most voltmeters are used multi-range voltmeters, which means they are designed to use 1 meter movement to measure several range of voltage. Like there is 1000, 300, 100. There is a multi-range selection for voltmeter. Okay. Then the reading a meter. Learning to read this scale of a multimeter takes time and practice. Most people use multimeters or meters every day without thinking about it. A common type of multimeter or a common type of meter is used daily by most people, like the speedometer or a speed meter, mile per hour or kilomile per hour, and a fuel gauge meter. They all use day-to-day life in their cars and bikes. Then, okay, the reading of voltmeter. How we can read the voltmeter in an analog, right? The pointer, the red one is the pointer, and the 250 is the value of the meter. And this is the AC and DC. This meter is rated for AC and DC. The pointer is located right above the 250. So the meter reading is 250 and 50 and 10. When we use an AC voltage with the range selected by the meter, if we select at 250 to 30, 200, the maximum is 300 ohm or 300 volt. When the pointer is at the 250, then we know the value is 250. The ammeter. The ammeter has a typical impedance, means impedance means resistance, load, resistance, capacitance, and inductance is less than 0.1 amp, sorry, 0.1 ohm. If this meter is connected in parallel with the power supply, this is very dangerous. The impedance of the meter is only thing to limit the amount of current flow in the circuit. Assume that an ammeter with a resistance of 0.1 ohm is connected across, means parallel, not in series, parallel to 240 volt AC line. The current flow this circuit would be 2400 amp. With this calculation, a blind flash of light would be followed by the destruction of the ammeter, means the ammeter is destroyed. Only use the ammeter in series, not in parallel. This is the ammeter, looks like DC ammeter looks like. And this is the another type of ammeter which uses the shunt. Sorry, this is the ammeter which uses shunt. Every DC ammeter uses shunt, and the shunt is located parallel to the ammeter, parallel to the moving coil. The multi-range ammeter, right? Then many ammeter called multi-range ammeter are designed to operate on more than one range. There is a caution for the multi-range ammeter is that when a multi-range meter is used, care must be taken that the shunt is never disconnected from the meter because when there is no contact between the shunt, the current flows from this positive to the directly to the ammeter, not the shunt. The current, the all the current when this is all the current is flow through the shunt is not flowing because instead of the ammeter, and the ammeter will destroy. So make sure to don't disconnect the series connection from the shunt and the source. There is another type of CT, it means current transformer. When a large amount of AC current must be measured, a different type of current transformer is connected in the supply line. These transformers have ratio that start at 200 to 5 and can have ratio to several thousand to 5. These current transformers generally referred to in the industry as CTs, and they're called a CT, the current transformer. Caution: the secondary winding of a CT should never be opened. Right? There is the secondary winding which is wound in the CT. The secondary winding of a CT should never be open when the power applied to the primary. This will cause the transformer to produce a step up in voltage that could be high enough to kill everyone who comes in contact with it. This is a diagram how we can connect the CT to measure the ampere. And the clamp on meter. Here is the CT, and we should pass the wire through this hole. But in this case, we don't need to pass a wire or the cut a wire to measure the clamp, to measure the resistance. Okay, this is the analog type clamp meter, which is vertical scale, which means the reading is measured by not waving the pointer, but instead of horizontal or vertical movement. And there is also a clamp on meter, which is the analog type meter, and the pointer is right over there. And this is the digital type clamp on meter. And we should clamp the meter across the wire. Either it's neutral or phase, because the current flow through the wires and back goes to the grid, and the current is always the same in both wires. Okay, so another is the AC and DC clamp on meter. The most clamp on meter that have the ability to measure the both DC and AC. We can measure DC voltage and DC current and AC current simultaneously or with a same meter. Let's talk about ohm meter. The ohm meter is used to measure resistance. The common volt milliohm ammeter or VOM contain an ohm meter. Means all the VOM means voltage, ampere, and current meter contain ohm meter, resistance meter, and this is the scale and this is the pointer. The pointer is deflected 0 to between 100 to 200. Okay, this is the another type of voltmeter. We can measure the volt. This is called the low impedance voltage tester. Another device used to test voltage is often referred to as a voltage tester. This device does measure voltage, but it doesn't contain a meter, movement, or digital display. Instead of the plunger is okay. Now, first we talk about this low impedance voltage tester diagram, internal diagram, you can say. This is the coil, the wire is wound on the iron core, and this is the spring which is load, which is tension to pull the plunger up. When the voltage is applied to the coil, the plunger is the coil is attract the plunger, and the plunger is go down, and the meter reading is shown in this in the range of voltage. And when the power supply is removed from the coil, the plunger is go back up in its position. Okay, so the watt meter, what is the watt meter? The watt meter is used to measure true power of one circuit. There are two basic type of watt meters, dynamic and electronic. The dynamic watt meters different from the Darnall type meter in that they don't contain a permanent magnet. They contain electromagnet and a moving coil. Right? The current coil means this is the electromagnet, not the permanent magnet. And the voltage coil is right center in between the current coil. And this is the spring which holds the coil, the moving coil in the zero position. And this is the pointer. Connection for a voltmeter. This is the connection for a voltmeter. And the digital multimeter. Digital multimeter have become increasingly popular in the past few years. The most apparent difference between the digital meter and the analog meter is that digital meter displays their reading in discrete digit instead of with the pointer and scale. This is the modern type of digital multimeter, and it supports RS-232 communication with the computer, and this is also it's also measure voltage, AC voltage and DC voltage, and millivolt in millivolt range, and frequency, resistance, ohm, resistance, capacitance, diode, milliampere. It's also measure milliampere, even microamperes. At the end, the oscilloscope is the modern way of measuring the voltage. Many of the electronics control system in today's industry produce voltage pulses that are meaningless to a VOM meter, means voltage ohm meter. in many instances to know not only the amount of voltage present at particular point, but also the length or duration of the pulse and its frequency. This is how they look. This is how the oscilloscope look like, and this is the probe which is inserted on the this channel, and this is the 1, 2, 3, 4, 5 channel oscilloscope. That's for today. Thank you very much.